Our planet Earth is ancient. Its story stretches back billions of years. Imagine a time before Earth even existed. There was only a vast cloud of gas and dust. This cloud was immense, swirling in the darkness of space. It was the birthplace of stars and planets. Our sun was born from this cosmic nursery, and so was our home, the Earth. This journey began about 4.5 billion years ago, a truly staggering timescale to comprehend. We are stardust, contemplating stardust. The solar system was a chaotic place back then. The young sun blazed at the center. Around it, material began to clump together. Tiny grains of dust stuck to each other. Gravity, the universe's great sculptor, pulled them closer. These clumps grew larger and larger over millions of years. They became small rocky bodies called planetesimals. Think of them as planetary building blocks. These planetesimals collided and merged, growing ever bigger. This process, called accretion, was violent but creative. It was the way our Earth started to take shape. Our proto-Earth was growing. It swept up material in its path. It became hotter and hotter with each collision. The energy from these impacts was immense. Radioactive elements within the young planet also decayed. This decay generated even more internal heat. Slowly, the Earth began to differentiate. Heavier elements like iron and nickel sank towards the center. They formed the Earth's core. Lighter materials rose towards the surface. This created the mantle and eventually the crust. This process took many millions of years. It is hard to grasp such vast expanses of time. Human history is a mere blink in comparison. The universe operates on scales far beyond our everyday experience. Yet science allows us to piece together this ancient story. We study rocks, meteorites, and distant celestial bodies. Each clue helps us understand Earth's epic formation. Our planet's beginning was a dramatic chapter in the cosmic story, a story that continues to unfold all around us and within us. The very early Earth was a hostile place. It was nothing like the blue marble we know today. Imagine a planet covered in molten rock, a glowing red-hot sphere. This was the Hadean Eon, aptly named after Hades, the underworld. The surface was a roiling ocean of lava. Asteroids and comets constantly bombarded the young planet. These impacts were colossal, releasing incredible energy. Each collision added more heat to the already fiery world. It was a truly hellish landscape, unfit for life as we know it. One of the most significant events in Earth's youth was a giant impact. A Mars-sized object, sometimes called Theia, collided with the early Earth. This was not a glancing blow, it was a cataclysmic event. The impact was so powerful it melted much of Earth's surface. A vast cloud of debris was ejected into orbit around our planet. This debris, consisting of material from both Earth and Theia, began to coalesce. Over time, this material clumped together. This is how our moon was formed, a constant companion in our sky. The heat from its formation and constant bombardment kept Earth molten. There was no solid crust to speak of, at least not for long. Any crust that tried to form would quickly be shattered by impacts, or it would be remelted by the intense heat from below. The atmosphere was also very different. It was thick with gases released from the cooling rock, gases like water vapor, carbon dioxide, and nitrogen. There was no free oxygen to breathe. This was a world still finding its form, still seething with primordial energy. Gradually, very gradually, the Earth began to cool. The frequency of large impacts decreased over hundreds of millions of years. As the surface cooled, a more stable crust started to form. Water vapor in the atmosphere began to condense. This was a crucial step. The early Earth was slowly transitioning from a ball of fire. It was on its way to becoming a water world. This cooling set the stage for the next incredible chapter. The chapter where life itself would begin its remarkable journey. As Earth continued to cool, something amazing happened. The vast amounts of water vapor in the atmosphere condensed. It began to rain. Not just for days, but for centuries, perhaps even millennia. This relentless downpour filled the low-lying basins on Earth's surface. This is how the first oceans were born. These early oceans were warm and rich in dissolved minerals. They were a chemical soup of possibilities. Comets, rich in ice and organic compounds, may also have contributed water. These oceans became the cradle for life. Within these ancient waters, complex chemistry was at play. Simple organic molecules began to form. These are the building blocks of life. Molecules like amino acids and nucleotides. Sunlight, lightning, and hydrothermal vents on the ocean floor provided energy. These energy sources could have driven the chemical reactions. Scientists believe these molecules accumulated in the primordial soup. They interacted, combined, and formed more complex structures. It was a slow, patient process of molecular experimentation. The universe is patient. Eventually, a truly remarkable threshold was crossed. Some of these complex molecules developed the ability to replicate themselves. This was the dawn of life. The first life forms were incredibly simple. They were likely single-celled organisms similar to modern bacteria or archaea. These tiny microbes, called prokaryotes, did not need oxygen. They thrived in the harsh conditions of early Earth. Many scientists think life might have first emerged near deep-sea hydrothermal vents. These vents provide warmth and chemical energy, a potential haven. The exact process of how non-living matter became living organisms, abiogenesis, is still a profound mystery. It is one of science's biggest unanswered questions, but we know it happened. The evidence is in the rocks and in our own DNA. This transition from lifeless chemistry to self-replicating biology was monumental. It transformed Earth from a barren rock into a living planet, a planet teeming with potential. This was perhaps the most significant event in Earth's entire history. Life had gained a foothold. For billions of years, life remained simple. Single-celled organisms dominated the planet. But then, a new type of microbe evolved. These were cyanobacteria. They performed a revolutionary trick photosynthesis. They used sunlight to make their own food. A crucial byproduct of this process was oxygen. Slowly, over vast timescales, these tiny organisms pumped oxygen into the oceans. Then, it began to accumulate in the atmosphere. This is known as the Great Oxidation Event. It changed Earth forever. Oxygen was initially toxic to most early life forms. Many went extinct. But some organisms adapted. They evolved ways to use oxygen for energy. This was a much more efficient way to live. The rise of oxygen paved the way for more complex life. Eukaryotic cells evolved with their genetic material enclosed in a nucleus. These were larger and more complex than prokaryotes. Eventually, some of these eukaryotic cells began to cooperate. They formed multicellular organisms. Life was becoming more diverse and intricate. Key events mark life's journey. The Cambrian explosion about 540 million years ago saw a rapid diversification of animal life. Complex creatures with shells and skeletons appeared. Life moved on to land. Plants colonized the continents, followed by insects and amphibians. Dinosaurs roamed the earth for over 150 million years. Their reign ended with another cataclysmic impact. This allowed mammals, our distant ancestors, to diversify and thrive. Each event, each extinction shaped the course of evolution. Our planet today is a testament to this long, epic journey. It is a vibrant world, full of incredible biodiversity, from the deepest oceans to the highest mountains. All life on Earth is connected. We share a common ancestry, a link back to those first simple cells. Understanding Earth's history gives us perspective. It shows us how precious and unique our world is. This 4.5 billion-year transformation from fire to life is a story of cosmic proportions, and we are a very recent but significant part of that ongoing story.